Welcome back. In this video, we'll continue working on that retirement simulation. Again, it's a good base case to build off of for the last homework assignment, which we'll talk about soon. And no mini exercise in this video, but let's get back into the spreadsheet. Right? Given some annual deposit assumption and then some assumptions about how portfolio returns are distributed, if we assume they follow a normal distribution, then we can build out how portfolio returns will work over time. They'll always be normally distributed. And then we can also see how the account balance changes over time, right? Start with $15,000, simulate a return, see how it grows. Then in subsequent years, we simulate a return on the beginning account balance, right? And then add $15,000 at the end, like we said. So let's copy and paste this over and see if it looks reasonable. And then it's always helpful to just double check our work to make sure that the cell references are either moving like we want them to move or staying put if they're supposed to stay put. And I think we've done our work correctly. So let me see if I can make this a little more readable. And we'll copy and paste this down and do 1,000 simulations. The nice thing about Monte Carlo simulations, it's easy to have a humongous sample size, right? Because you can just keep simulating more and more rows of data. I've got 1,000 simulations here, but depending on processing power and memory and storage, you could have 10,000 or 20,000 easily. And let's look here. If you just look at the first three rows, right? The first three simulations, we've got a range between 400,000 and 1,000,000 and 772,000 as the ending account balance, right? And but we can use our entire set of simulated outcomes to give us a pretty rich range of values, right? So remember, let's find the various percentiles, percentile exclusive or percentile inclusive. They should give us about the same result with a large enough sample size. But let's find the 10th percentile of ending account balances, right? This is one of the main benefits of Monte Carlo simulation is we get a range of outcomes. So the 10th percentile of these 1,000 ending account balances is about $400,000. And then we can do the same thing for the 25th, the median, and the 75th percentile. And just change the number format. So we saw when we did just a point estimate, assuming returns weren't variable at all, we saw our point estimate of the ending account balance was $686,000. We can see that when returns are variable, we get a range of possible outcomes. So this is helpful for planning purposes, right? If I'm planning for my retirement, I'm going to look at some, probably look at the more conservative cases, right? Look at the lower percentiles and say, okay, what if we've got 20 bad years leading up to my retirement? How much am I going to have saved? $400,000, right? So we get a range of possible outcomes. So in this video, we built out this retirement simulation spreadsheet. In the next video, we're going to talk a little bit about how to adapt this really simple model to the fifth assignment, which I'm hoping you're going to put a lot more thought and more rigorous assumptions into. All right, thanks as always for tuning in.